In this video series, I have worked through a math problem or problems each video. Some inequalities are actually combinations of two mathematical sentences. For example, the statement x is less than or equal to 10 combines x is less than 10 with x is equal to 10. Note that since the number can't be both less than 10 and equal to 10 at the same time, a maximum of one statement is true for any real number we choose for x. Another way inequalities can be combined into a single statement is by having a number or expression that is bigger than another number or expression and smaller than another number or expression. For example, 3 is less than x is less than 8. Is a combination of 3 is less than x and x is less than 8. Note that a number that satisfies the original combined inequality must satisfy both of the regular inequalities. Let's take a look at the examples. Solve and graph the following inequalities. First, we have 2x plus 4 is less than or equal to 8. To solve this inequality for x, let's first subtract 4 from both sides. This gives us 2x is greater than or equal to 8. Next, we can divide both sides by 2. The direction doesn't change since we're dividing by a positive number, and we end up with x is greater than or equal to 4. This is a combination of the sentences x is greater than 4 or x is equal to 4. So a number has to satisfy just one of these two. The number can't satisfy both of them at the same time, but it could either be equal to 4 or it could be bigger than 4. If we graph this on a number line, the number can be equal to 4, so we fill in this dot, and the number can be bigger than 4, so we draw the arrow in this direction, and this represents the possible values that x can take on. X is equal to 4 or x is greater than 4. Next, we want to solve the combined inequality minus 4 is less than 3x plus 2 is less than 11. First, let's subtract 2 from all parts of the inequality. We get minus 6 is less than 3x is less than 9. Next, let's divide all three parts by 3. Minus 6 divided by 3 is minus 2. 3 and 3 cancels out, so we are left with x, and 9 divided by 3 is 3. This combined inequality can be separated into minus 2 is less than x and x is less than 3. In this case, all the x that we're looking for have to satisfy both of these inequalities. It has to be bigger than minus 2 and also less than 3. On a number line, we can represent these numbers by a line segment without the two endpoints because we're excluding minus 2 and 3, but want to include all the numbers in between these two numbers.